Hi there, welcome to the first video in my series on partial fractions. And what I want to do is just show you what we mean by partial fractions. But before I do that, just want to take you back to subtracting and adding fractions. If we had something like this, the first thing we'd want to do is just say that this is identical, and we would put it all over a common multiple, the lowest common multiple of x plus 2 and 2x minus 1, which would be x plus 2 multiplied with 2x minus 1. And then in the usual way, we'd just say, what do we multiply the bottom here by to get this denominator here? So x plus 2 would be multiplied with 2x minus 1. I would do the same to the top. We'd multiply the 3 with the 2x minus 1. And then for this second fraction, what do we multiply the 2x minus 1 by to get this denominator? It's the x plus 2. So we'd multiply the top there, the 4, with the x plus 2. And you should be familiar with this. If not, do check out videos that I've done on simplifying fractions like these. Okay? So on that basis, if you were to simplify this, what you would get would be this. 2x minus 11 all divided by x plus 2 times 2x minus 1. Now the point behind doing this is that when it comes to partial fractions, what we're doing is taking some fraction like this and then splitting it into, well, in this example, two other fractions. Two fractions that give us this result. And that is called partial fractions, when we take a fraction and split it up into other fractions. Now when it comes to working with partial fractions, we have to look at the kinds of factors that we've got in the denominator here. And in this example, what we've got are called linear factors. They have the form ax plus b. In this example here, x plus 2, the a would be 1 and the b would be 2. And in this factor here, a would be 2 and b would be minus 1. So we've got linear factors. And when you have a fraction like this containing linear factors, we can see that what they've come from was a constant over each of the linear factors. So as you can see, we've got a constant 3 over one of the linear factors, x plus 2, and then we had another fraction where we had a constant divided by the other linear factor. And this always happens. So if you had an example like this, where we have to express a fraction in partial fractions, and it's this fraction here, we can see that in the denominator we've got two linear factors, x plus 3 and 5x minus 1. And what this would give rise to would have been that it would have come from something like this. A constant, we'll call that constant a. You can choose any letter you like, it doesn't matter. Choosing a though, over the first linear factor, x plus 3. And then for this other linear factor, we'd have another constant, and I'll just say plus b, divided by that linear factor, 5x minus 1. So these would be our two partial fractions. We'd need to work out what those constants a and b were. And I'll show you how to do that in a later video, but that's not the aim of this video. It's just to be able to get you to see what types of partial fractions we can get then from a fraction like this. Now, not all fractions that we get contain linear factors, and that's why I've got this second example here. You can see how it differs from this first one. We've got three fractions, for instance, and two of them, this first one and this last one here, contain linear factors. The x minus 2 is a linear factor and the 2x plus 5 here is a linear factor. But this factor here is a different kind of factor. It's called a repeated linear factor. But let's just see what kind of answer we get when we're working something like this out. I'd first of all start to think about what my lowest common multiple is going to be. And it's not going to be all three of those multiplied together. X minus 2 is a factor of x minus 2 all squared, so it's sufficient to pick x minus 2 all squared times the 2x plus 5. Then if we're going to work out what we get in the numerator here, then for this first fraction we're multiplying the x minus 2 with another x minus 2 and 2x plus 5. So you're going to get 4 times x minus 2 times 2x plus 5. For the next fraction here, x minus 2 squared has to be multiplied with 2x plus 5 to get that denominator. So we multiply the 2 up there with 2x plus 5. And then finally, for this last term here, the 2x plus 5 is multiplied with x minus 2 squared to give that denominator. So we multiply the 3 then with x minus 2 all squared. So when you simplify the numerator here, the final fraction you get is this one, 11x squared minus 4x minus 18, all divided by then x minus 2 all squared times 2x plus 5. So this factor in the denominator here is a linear factor, and this one here, x minus 2 all squared, is called a repeated linear factor. And you can see that if we reverse the process, taking this fraction here and asked to split it into partial fractions, then these would be the 3 partial fractions. What you get is a constant, this case the 4, divided by the first linear factor, x minus 2. Then you get another constant, 2, divided by the repeated linear factor. Okay, so we write the x minus 2 all squared, and then for the last term here you've got another constant, 3 in this case, divided by the linear factor. So when it comes to examples like this, let's just take this example, 2x plus 1 divided by the repeated linear factor 3x minus 2 all squared. What kind of partial fractions would we get for this? Well, being a repeated linear factor, we're looking at 2 partial fractions. The first one would be a constant, I'll use the letter a, divided by the linear factor 3x minus 2. Then we would get another fraction, so we'll just put plus, another constant, I'll call it b, and that would be divided by the repeated linear factor 3x minus 2 all squared. Now you might have another one that's a bit more advanced than that. In this example I've got 5x minus 1 all divided by x minus 2 times 2x plus 1 all squared. So with this one it's very similar to what we've got here. We've got a linear factor and a repeated linear factor. So if we handle the linear factor first of all, that's going to be a constant, which I'll call a, divided by the linear factor, x minus 2. Now if we look at the repeated linear factor, we're going to get another constant, which I'll call b, and that will be divided by just 2x plus 1. And now we have a third fraction, which we'll say has a constant c, divided by the repeated linear factor, 2x plus 1 all squared. Now in any of these examples we need to work out what the constants a, b and c are. And so a, b and c are constants to be found. And in a later video I'll show you how we go about finding those constants a, b and c. And in the next video that follows, I've just got a quick test on what we've just been talking about here, which I certainly encourage you to try. It won't take that long to do, but it's about expressing fractions then in partial fractions, just using constants a, b and c and so on. Okay, so do try that, and hopefully you'll carry on with the other videos in this series then on partial fractions.